Welcome! In today's episode I designed new landing gear in SOLIDWORKS for my large-scale RC plane. I am also going to show how I made this animation. I will need GT2 pulley set, tapered bearings, power resistors, brushless motors, roller bearings. Let's start with the pulley first. I start with the new part. I start a sketch on the top plane. I draw a circle, dimension it and use extruded post base. I go with 1 mm to make the outer plate. I guess this dimension, but I need to stick to the specs of the total size. I select the top face of the object and start a new sketch. I draw another circle, dimension it and extrude again. To make sure my new circle has the same center as the previous one, I hover over the outer ring and see the center point pop up. I will do it many more times, so pay attention to this. I extrude only 5 mm, so the upper plate is 1 mm and makes it 7 mm in total as it is on the picture. New sketch on top and hover over the outer ring again. I give it a dimension as per drawing. In SOLIDWORKS you can use different units, you just have to type it after the number. If you don't, it will assume default unit set in options. I draw another circle on top of the last one. This time I extrude it before I give it a dimension, just to show that it can be changed at any time. To change it, I click on the last extrusion and choose the sketch. I enter the sketch and give it a dimension, 30 mm as per drawing. You could easily find this part online if you don't feel like drawing it, but that's not the point of this video. I draw the last circle on top, but this time I use extruded cut. I select the option to cut through all. Okay, this is good enough for what I need. I save the part and I'm on to the next one. I create a new part and draw the smaller pulley the same way. I fast forward the video more so I don't bore you. I make sure to save all the parts in the same folder. Next, onto the tapered bearing. I make a new part and get to drawing more circles. It doesn't really matter in which plane you start the sketch. When you drop all the parts into the assembly, they will appear the way they were sketched in the part drawing, but you can always flip them in any way you want. I make this mock-up really simple, I just make sure to stick to the critical dimensions. Next, the brushless motor, which will act as my brake. To your surprise, I draw some more circles. The motor is marked as 40 to 50, meaning that the enclosure is 42 mm in diameter and 50 mm in length. The shaft length is not specified, so I had to measure it. Next, the power resistor. New part, and this time I start with the rectangle, but not without a circle. I draw a construction line to help me to align the side of the circle with the side of the rectangle. I trim the overlapping parts of the figures to get one shape. It becomes colored inside once the shape is valid. Now I can extrude it. Of course, I stick to the dimensions from the drawing. Now I want to add the mounting holes. I hover over the line to get the center point to pop up. I select the line and the center point while holding control, and I set the relation to coincident. I draw and dimension the circle and mirror it about the center line. I select extruded cut feature and make the holes. At last, I extrude the contacts of the resistor. I eyeball the diameter, but I stick to the drawing dimension with the total length. I save it with all the parts. Now, time to make a mock-up of the 5-inch wheel. Circles again. Extrude and cut are probably the most used features today. I use fillet feature to make the corners round. I also make a middle plane for the wheel to mirror the rim cut to the other side. I go to the reference geometry and add a plane. I click on the two outside faces of the wheel and the middle plane gets created automatically. I select the extruded cut, which makes the rim on one side, and I use mirror feature to get the same cut on the other side. Of course, the mirror plane is the one we just added. I click on the linear pattern and select mirror to access the mirror feature. I save it with all the parts. Roller bearing is next. This is a super simple mockup, so I just fast forward again. There is a toolbox with various bearings and fasteners inside the SOLIDWORKS, but I don't use it for now. Next, I get to make the plate which will hold all the components. I could probably call it the trailing arm suspension. It will be made out of 1/4" aluminum, and I'm just giving it a rough shape. I can always change and adjust it. I save the part with the rest. I make a new part to create a mock-up of my landing gear leg. On the top plane I sketch the shape of the 3/4 aluminum tube with 1/16 of an inch wall thickness. I exit the sketch and start a new sketch, but on the front plane this time. I need a guideline for the feature called swept boss base. Once the two profiles are ready, I use the swept feature. I first select the profile to be swept and then the path of the sweep. There we go. Simple mockup is ready. I save it. Next, I make the knuckle which connects the landing gear leg with the trailing arm. I need one side of it to be flat, so I draw a square and perform extruded cut. I could have drawn the square at the bottom of the cylinder, but as you see, there is more than one way to achieve the same result. The only trick is to make it easy to adjust at any time. The last part before I start the assembly is the housing for the tapered bearings. Tapered bearings are always installed in pairs. Let's see how the housing for them could look like. I know that this landing gear with brakes will be extremely heavy but also super strong. I want it to last many rough landings without any problems. The bearing races will be pushed in from both sides and blocked by the groove between them. The shaft, which I will make later, will be holding the bearings together from sliding outside of the housing. Finally, I get to the assembly. I insert the gear leg mockup, and by clicking on the tick mark, the piece automatically gets snapped to its origin. The knuckle goes in next. I use mate feature to make the two parts concentric, and I also make the end of the tube coincident with the top of the thicker section of the knuckle. The part is still free to spin, so I make it parallel to the one of the main reference planes of the assembly. I also go back to the part and make the top of the knuckle a bit shorter. I insert the tapered bearing number 1. I make it concentric with the hole in the knuckle. I also set the two parts to be at certain distance apart for now. Of course, I use mate function to set all these relations. I insert the bearing housing next. I make it concentric with the bearing. And I make the side of the bearing coincident with the shoulder inside the housing. I set some colors for the parts so they don't blend in and stay easy to distinguish. I right click on the part and set the appearance for the color that I want. I insert tapered bearing number 2. Nothing new here, same as the other side. I insert the plate. I made the whole of the plate concentric with the bearing. I also set it to a distance from the bearing for now. The arm is free to move around the hole. Only this gear leg mockup looks way too small, so I open the part and adjust the sketch. After I save it, it automatically gets updated in the assembly. Okay, better now. I open the arm part and add some more holes. I ask Google what will be the distance between the pulleys for the given belt length. 72.47 is the answer for this case. I set this distance between the center of the wheel and center of the motor. I rounded the bracket at the top. This is just a rough idea for now. I will very likely add some tensioner later on for two reasons. One, to get the motor closer to the center of the wheel so the bracket gets smaller. Two, tensioner will not only help to minimize the distance but also will increase the amount of teeth wrapping around the pulley, thus eliminate the chance of the belt slipping. The brushless motor comes next. Again, concentric with the hole and coincident with the plate. I also set the wheel to some distance from the plate. I insert the pulleys next. I keep setting the mates in a similar manner. I do make sure that the belt lines up in one plane for both pulleys. Just by looking at it, I can tell you that in next episodes we will have to come up with some weight reducing techniques. Whatever we made so far weighs more than 800 grams without even including the gear leg. Next, I go to the arm part and make some adjustments. I'm still tinkering and I don't have 100% plan of how it's all going to work yet. I'm sure this design will still change quite a bit. I insert the resistors. The function of those is to dissipate the energy generated by braking. I assume they will get pretty hot, that's why they need to get mounted to the aluminum arm, which will act as a heat sink. It's already getting tight here, but I need 2 of those. Ball bearing is the last piece. I don't have any housing designed for it yet, but I can already see that the resistor is too close to the bearing and leaves no room for any housing. I have no choice but to find a better spot for it. Okay, not a final decision, but better. Finally, the promised animation. I click on motion study on the bottom bar. I set the camera to the starting position. Once I'm happy with it, I right click on the diamond beside orientation and camera view. I click replace key. Then I slide the time marker to a 2-second mark. I rotate the camera view around 90 degrees. I insert a keyframe at the 2-second mark. Okay, we got some movement. Next, I move the time marker to 4 seconds, then I move the view another 90 degrees around the gear. I place another key for this position. We already have half of the rotation. Time marker goes to 6 seconds now. I repeat the process. Move the camera, insert keyframe. I press play button once finished. The last step is to save the animation. I click on the save icon and give it a name. I change the frame rate to 60 FPS for smoothness. It's rendering now. By default it gets saved in the same folder with the assembly file. It's ready to play now. That's all for today, and more coming soon.